All right, Ken.
We are ready. Okay. Well, good morning, everyone, and welcome to Lakeville Rotary, the May 14th virtual club edition. We're glad to have all of you here. As we usually do, let us start with our Pledge of Allegiance. And I was going to ask Mr. Bob Bear if he would please lead us in that this morning.
Say, Ken, this is Jim. Could we remind everybody about muting and protocol for any guests?
Sure, we can do that. I was going to do that afterward, but that's fine. Just a reminder that you are being recorded and that this morning, if you're not speaking, please be kind to the other members and keep your speaker on mute. And we will remind everybody that you are on both video and audio recording, so the pants rule should come into play. Did I miss anything, Jim? We good?
Nope. I think that's great. Thank you.
All right. Mr. Bear, if you would, please.
Yes, sir. Thank you very much. Good morning, everybody. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
Thank you, Bob. Mr. Christian, would you please lead us in the invocation, please?
Jim, you're muted.
So, thank you. Please bow your heads in prayer. Sometimes we're surprised when a business that seemed to be thriving closes its doors. The restaurant that succeeded in one location but scaled too quickly. The online education platform with a big production budget but not enough students. The great cause or nonprofit that couldn't attract the support required to create an impact and sustain. Our culture has taught us that we should multiply our effort to maximize our reward, but a sustainable business or life, one that is viable and healthy because it delights customers and creator alike, doesn't always depend on exponential growth. Success isn't only about doing all we could do. Often it's about doing the best we can do, purposely making incremental improvements and being able to do it again tomorrow. For many of us, that is more than enough. Dear Lord, we give thanks to you for our Rotary family that helps us multiply service to others and remind us what we've each been given is a gift from God. What we do with it is a gift to God. Lest we forget, bless the food for those of us who have already eaten or will be eating and the hands that prepared it. Amen.
Thanks. For some reason, it wants to keep me muted this morning. Okay. Well, thank you for that. And once again, good morning. And especially, we'd like to welcome our guests this morning. We have Dr. Laura Niedenhofer and Dr. Paul Robbins from the University of Minnesota who will be speaking this morning. And we will have a little more to say about them. Chad Fanning, I'm sorry I forget the name of your organization, Chad.
Yep, I work at Weber Johnson. We're public affairs. We work with community and government relations at the University of Minnesota. So we do these presentations all over. So happy to be here again.
Well, I'm glad to have you here. And Nancy Hanson, glad to have you here, Jim's mother. I hope he lived up to expectations this morning.
Very much so. Very much so.
Always glad to have visitors with us. Did I miss anybody else this morning?
We have Juju who's listed.
Juju.
And then we have a Randy who's joining us.
Okay. Well, if you'd like to identify yourselves and if you're with Rotary, not with Rotary, we'd appreciate that. Thank you.
And then we have a Diorins. Okay.
That would be Dee Dee Orens, one of our clients. So
okay,
hello,
great.
Dee Dee.
The Juju, I apologize. That's Justin Miller. My
Oh, okay.
my daughter got a hold of my Zoom and put her nickname in there. I apologize for that.
That's okay. Glad you're here.
Well, we'll just remember you with a different nickname now, Justin. Good morning.
Thank you.
Yes, it's always interesting when kids interface with technology, and especially when you don't know about it. So, well, anyway, everybody, all of our guests this morning, we're glad to have you here. We are excited. We've been waiting for this presentation for a while, so we're looking forward to a good program this morning. Before we get to that, we have a few announcements to make. I think, Richard, you have an update, and we have a meeting this morning afterward. You want to tell us a little bit about Taste of Lakeville, where we stand with that?
Yeah, good morning. Quick Taste of Lakeville update. We're note the meeting afterwards. We'll start right away and try to keep it short as we can. So if you're on one of the teams, please stay on afterwards. We're still tracking for the August 26th date. It's fallen into place pretty well. Just a couple of highlights. Reminder that we'll be integrating in community support and giving them some space on the grounds for the community to interact for community support during Taste of Lakeville. Couple questions on tickets. We're still not, kind of holding off, not putting our ticket sales into place, but over the next couple of weeks, we'll be rolling out a plan. But just please keep thinking about it. We still need all members to sell tickets. We've still got a few holes in areas where we need support. If anybody would like to step up, and also be thinking about auction and what your auction item would be, or joining up with some other members to purchase an auction item. And not to put Adam on the spot, but I don't know, Adam, did you have any update on anything you wanted to put out on auction? I tried to call you on this morning, but I'm not sure.
No update today, Richard. I can give an update next meeting.
Okay, I'll give you more than a 60-second warning next time. But no, it's pretty good. Should have a notification coming out in this week, the newspaper, on the change in date and the change in venue. And so hope things are falling into place, and please stand by afterwards for the meeting. So thank you very much.
Okay, Richard. Well, thank you for that update, and we'll remind everybody before the end of the meeting for the taste meeting afterwards.
Right.
Hey, do now. We had some activity this week on our COVID emergency grants. Would you like to share a little bit about what we accomplished this week?
Sure. I don't know if everybody knows, but Rotary International donated or changed the designation for a chunk of funds, and part of it went to each district could apply for the funds. Our district applied for $25,000 that could be used for each club that they applied for, and $25,000 to go out as a district. We did apply for a grant, and it was a dual grant with Lakeville Cares. Part of it was to help drive through feeding, or whatever you want to call it. They fed like 4 people, like 2 or 3 meals that are cooked, and people would pick those up, or else boxes that contain 4 meals for 4 people for a time. That was one of them, and Hosanna Church was the one that was doing that. The other was for the first responders here in Lakeville, and apparently the high school has some, what do you call it, 3D copiers, and they brought them over to a company by the name of AQ1 Precisions, and they are making 600 face shields for our first responders. That was the second one. So thank you, club, for putting our donation in, and it was really a worthy cause.
Well, thank you, Peg. Thanks for handling all of that. I believe the first responders, wasn't that through the Lakeville Cares platform?
Both of them were through there.
Both, okay.
I got one more thing. I just wanted to remind everybody that there is a Shark Tank event coming up on May 20th. What that is kind of like a Shark Tank where the district grant committee is, thank you, Kathy, there it is. It sounds like it would be great fun, and our own Jim Christian is a shark. So please come and join the fun, and I think it should be fun. Great. There's 3 different Rotary clubs competing here for money. So I hope I see you there. Thank you.
Thanks, Peg. And nice segue. You saved me an announcement on that. Yes, we'll all be rooting. We'll be rooting for you, James. We'll be there for you. So anybody that can join, I think it will be a fun time. I saw the announcement from Chris Casey. Is Chris on this morning? I don't believe I saw him on. Chris, are you on this morning?
Actually. I'm here.
You are? Oh, awesome. Great.
I am. Yeah.
Good
just
morning.
No video. Good morning.
Would you like to tell us about the Boy Scouts and kind of what we're doing to move forward there?
Yeah. Well, what we need is, and I've actually had some good response on this so far. They need a couple things. One, they need space to meet. And the other thing is they need space for their new trailer. And we've had a couple people reach out to me via email. And then I was able to email them like the requirements, what they needed for the space for the meetings, the requirements for the space for the trailer. And they're just in the process of getting back to me. So, but it takes a while to find that type of stuff. So it'd be appreciated if people could, keep that in mind that, the troop that we do support is in need of space for a trailer as well as a meeting space. So, but if people do have questions, feel free to reach out to me about their needs.
Okay. And while I have you on the speaker circuit here, I noticed that we have the South. Thank you, Kathy. Kathy knew where I was headed. On the May 15th, this Friday, we have the senior scholarships, and I assume we have some Rotary scholarships there, Chris.
Yeah. So on the scholarship side of things, there is obviously scholarship money given out to both schools, Lakeville North and Lakeville South. And the awards presentation for South is for sure going to be tomorrow. And I believe North's is tomorrow as well, too. And I've been working on getting the appropriate links over to Kathy so she can distribute to the club the link so people could watch it. But all of our Strive scholarships, as well as the Service of Above Self scholarships, will be given out at the respective schools.
Okay, well, good. And we will certainly make those. If you get those links in, we will certainly make those available.
Yep, I'll be looking for them. I'll pass on as appropriate.
Super. All right. Well, thank you, Chris. Appreciate
You're
that.
welcome.
And the only other announcement I had was we have our Lakeville board meeting will be next week on Wednesday, 5/20, and we'll put a notice out to that. Of course, everybody's always invited to attend. And with that, did I miss anybody that had any other announcements that we need to bring before the club? Well, okay then. Quiet group this morning. Well, I would like to give a little bit of an introduction to our speakers. This presentation has been given. Chad, you probably know more than I do about how many other Rotary clubs they've made this presentation to. But feedback has been quite positive on it. So, Dr. Laura Niedenhofer, I hope I didn't destroy your name there, Laura.
No, that was great.
That was pretty close.
Okay, well, I figured I couldn't be too far off. But Laura joined the University of Minnesota in 2018, excuse me, and she directs the new Institute on the Biology or Metabolism. And she's one of the 4 medical discovery teams at the U. She's also a professor of biology, biochemistry, molecular biology, and biophysics. Dr. Niedenhofer's expertise is in DNA damage and repair, cellular senescence, and aging. And I would have to tell you, I wouldn't even know what half of that would be. So it's very impressive. Prior to moving to Minnesota, Laura was at the Scripps Institute, and I believe, I'm sorry, my page ran out here. Let me get to a different track here. Okay, so the Scripps Institute, a research institute where she helped spearhead identification of a new class of drugs called senolytics.
Mm-hmm. Correct.
And Laura, she also studied at Duke University and completed medical science training at Vanderbilt School of Medicine. She's been recognized for research in aging, cancer, and environmental health science, and was a 2018 recipient of the Vincent Cristolfo Rising Star in Aging Research, awarded by the American Federation of Aging Research. My apologies, Laura, for kind of chopping that up, but we're glad to have you here. Her associate, Dr. Paul Robbins, is the Associate Director of the Medical Discovery Team on Aging and the Institute on the Biology of Aging and Metabolism, and Professor of Biochemistry, Molecular Biology, and Biophysics at the University of Minnesota Medical School. And before coming to the U, Dr. Robbins was a Professor of Molecular Medicine at the Scripps Research Institute in Jupiter, Florida, and Director of the TSRI Center on Aging. Prior to that, he was a Professor of Microbiology and Molecular Genetics, Director of Basic Research for the Molecular Medicine Institute, and co-director of the Paul Wellstone Cooperative Muscular Research Center at the University of Pittsburgh School of Medicine, as well as the interim director of the Molecular and Cellular Oncology at the University of Pittsburgh Cancer Institute. Dr. Robbins received his BA from Haverford College, his PhD from UCal Berkeley, and worked as a postdoc fellow in the laboratory of Dr. Richard Mulligan at the Whitehead Institute for Biomedical Research at MIT. He has co-authored over 385 peer-reviewed manuscripts, 190 book chapters and reviews, and 50,184 magazine articles. So with that, thank you very much for being here with us this morning. Thanks for being patient with us. And with that, I would turn it over to Dr. Laura and Dr. Paul.
Well, thank you so much, Ken, and thank you all of the Rotary members for inviting us to join you. Thank you, Tad, for organizing this too. So we are a husband-wife team of scientists who moved to Minneapolis in July 2018 to start this new medical discovery team. So I'll give you a little background on that and start the slides here. So about in 2015, I think it was, the state of Minnesota came to the U and said, what are really important topics that we need to create some new infrastructure for? And so there was a competition across the campus in all the different disciplines to identify key areas where things are going to change dramatically over the next decade or so. And one of the areas was aging, with our aging demographics in our population. So this is one of 4 medical discovery teams on the biology of aging, and it was elevated to a level of an institute, which means that we report directly to the dean as if we were a department on the campus. The other 3 medical discovery teams are one on rural health and health disparities, which is housed up in Duluth. There's also one on really high-end neural imaging, which is going to be critical with our aging population as well. And a 4th one on addiction and opioids, which also is obviously a pressing crisis. So we're really grateful to our state legislators for their wisdom and their generosity to allow this. And we're really excited to be at the U. I just wanted to segue a little bit and say, I don't know how much information you're getting about what the university is up to during this pandemic, but I have to say, through weekly updates from leadership, I am so incredibly impressed with the leadership and just the get-to-itness of all of the scientists there. They are developing tests for both detecting the virus and then detecting if you've mounted an immune response to that virus and therefore could be considered safer. And just an extraordinary amount of effort and working really furiously. So that what they've accomplished in just 2 months has just been pretty dramatic. So I'm really proud to be part of this effort.
And clinical trials.
Yeah.
Multiple clinical trials, and establishing a separate hospital simply to treat COVID patients. So it's been a very impressive tour de force of what they've done working with the governor and Mayo Clinic and the Department of Health.
So we're going to do a short tag team presentation describing what our institute and our research program is up to. So we usually start, hold on, there we go. So we usually start with some sort of introduction in terms of trying to establish the significance of our science. It's really important when we seek funding to just talk about how big a problem we're trying to tackle. And we actually view our aging population as probably the biggest biomedical challenge before the pandemic. Now there's a lot of argument about what's most important. But of course, those are interwoven too, because the pandemic is unequally having effects on the elderly population. But what this first slide shows is a graph, and on the bottom row, you're seeing age of people. And on the vertical axis, you see the number of deaths. And there's two curves here. And one in black shows what was going on in 1900. And in blue, you see more recent data. And basically what this is illustrating is that all of our wonderful biomedical research has essentially squashed infant mortality and early deaths for a variety of different reasons. And this is improvement in cancer therapy and heart disease, et cetera. But right now, what we're faced with is a population that happily can reach 70, 80s, 90s and above, and can count on that. But the problem is what's now happening is there's a population that's up here in what we call the red zone. And the red zone, as you see the shading, is illustrating increased morbidity in this population as they age out. So if we really wanted to move the needle on improving the health of people on this planet, we have to tackle this group as our top priority. So the reason this is so pressing is if you look at a map, and this is illustrating the world in different colors, depending on the fraction of the population that's over 65. So in Africa in red, you see less than 5% of the population is over 65. But in Japan and Europe that are in blue, you already see a healthy portion of the population that's elderly. And this is what the map looks like today. But if you go out to just 2050, you see this incredible shift. So the number of individuals over 65 and the number of individuals over 85 is anticipated to triple by that time period. And what worries us is many will have morbidity or diseases of old age. So again, this is age on the x-axis or horizontal axis. And then on the vertical axis, you see the number of, or the fraction of people with a number of disorders. So 0 in light blue to up to 8 as you get darker. And so if we put a vertical line right at 65, and then a horizontal line, it illustrates that 50% of people over 65 will have at least two age-related diseases, but 25% of the population is going to have 3 or more. So this is pretty alarming in terms of the impact of disease on the population. So what we've done historically, this is the National Institute of Health that has an institute for cancer and one for heart disease and one for lung disease, is we try and identify risk factors. And this is just an illustration for heart disease. So if I asked you what increases your risk of disease, we all know that high blood pressure or smoking or high cholesterol or having diabetes will increase your risk of heart disease. But if we put that on a scale of what just being old does for your risk of heart disease, you can see it dwarfs it by 1,000-fold. So we have these huge industries creating drugs that target each of these pathways, your statins for cholesterol and ACE inhibitors for hypertension. But what we're thinking is we should be targeting old age instead. And what's intriguing is I could have done these graphs for Alzheimer's disease or cancer, and they would show you the same data. So this is really, I think, a new paradigm to think about treating aging as a way to reduce disease in our aging population. So one more illustration of this is that, again, this is all-cause incidence of disease. So these diseases that are familiar to you all as being part of old age. And you see a dramatic inflection point here at 65 where the incidence of all of these goes up really sharply. So our question is, could we start treating aging and prevent all of these diseases in suite? And so what we think this novel approach is going to do is help prevent, delay, or ameliorate multiple of these chronic diseases with one intervention. This will help people avoid polypharmacy and the risk of side effects or drug interactions. It will also help us prevent spending the rest of your life with ologists, neurologists, cardiologists, you name it, which is no fun. And this is estimated to have a huge impact on healthcare costs, with perhaps as much as saving $7 trillion over the next 50 years. Another statistic I've heard is with our aging population, the cost of treating Alzheimer's patients in the next 50 years is going to be equivalent to our defense budget, our federal defense budget. So you can imagine that that's just untenable. So one more graph to show, well, a couple more graphs to show you. This is going out in time on the horizontal axis, and the millions of people up here who are healthy in old age. So this is where we stand right now with the blue line. So let's say we cured cancer. It would not move that line and increase the fraction of healthy people very dramatically. So on a whole in our society, we would not have a healthier population. If we cured heart disease, still, again, no impact on the health of our society. But if we found a way to actually delay aging a little bit, we believe it would shift this curve quite dramatically, and you'd have tens of millions of people who are healthier. So this is on a population basis, but what does it mean to you? So this is an illustration of common age-related diseases. And what we're trying to illustrate is in the blue area, there's no symptoms, no problem at all, but there's sort of a slow decline. Get frank disease when you're out here in the red zone. So in this illustration, if an individual had all of these risk factors, what's the shortest bar is cardiovascular disease. So this is meant to illustrate that this individual would succumb to heart disease. But let's say we cured it, got rid of heart disease, then this person would then ultimately die of cancer or diabetes. But the problem is they're now in the red zone in multiple of these bars. So it means the person would die of diabetes, but already have signs of dementia, already have signs of frailty, and would be facing a diagnosis of cancer. So not to be doom and gloom, but it's trying to illustrate a new paradigm where if we just treated aging, we could maybe get rid of all of these, this red zone for all of these diseases with one intervention. So what our goal is to square this curve. So normally as you live your life, you stay very fit, but there's unfortunately for many this sort of slow period of decline. So it's a real embankment here of increasing diseases. So what we're hopeful we can do is if we treat aging, we square the curve. So you'd stay very fit and then just sort of crash very precipitously. And what we call this is an effort to extend your health span, but not necessarily your lifespan. So here at the bottom, you do see a slight increase in lifespan, but we call this a side effect. What's really important is squaring this curve to keep everyone healthy. So we actually think this is possible, and I want to give you two pieces of evidence why this is. And one is we all know families where there's multiple centenarians. So people who live into their hundreds, and they're just remarkably healthy, fit, and engaged in society. So we're asking the question, do you want to age like this woman on the right, who's got her oxygen and she's checking her blood sugar levels, Or would you like to age like this woman who's out and about doing charity work, dressing to the nines, and really enjoying a social life? And I think it's possible. I think this is teaching us that human biology will allow us to live like this and not like this. We just have to figure out how to capture that. So the other reason, let me make the point too, that is we know that centenarians actually get 20 more years of disease-free survival compared to the average population. But really importantly, in the end of life, they spend 2.5 times less on healthcare than the average population. And so what that means is they're not in the hospital, they're not taking lots of medicine, and they're not seeing their doctor all the time. So this is what we're aiming for. So the second item, or piece of data that gives us confidence that this is possible to treat aging, is a curve shown here. So many of you may know of the drug called metformin. It's used to treat diabetes, or another name for this drug is glucophage. And so it's been used for 60 years in people all across the world. And so we have tons of data on what's going on in people who have taken metformin. And so this is showing survival of a diabetic who's taking something other than metformin. And this is compared to, in red, non-diabetic controls. So this is exactly what you would expect. The diabetic is not going to survive as long as the non-diabetic. However, this is a diabetic who's taking metformin, and this is their matched group, which is black. So what it's illustrating is diabetics who take metformin outlive people who don't even have diabetes. And this is remarkable. And when we go back and look at the data, we actually find that those on metformin or glucophage have decreased risk of cancer, they have less heart disease, and they have delayed cognitive decline. So what this means is metformin is doing what we've already promised to try and shoot for, which is it's treating 4 different age-related diseases. It's not just about diabetes, but it can help delay or suppress 4 age-related diseases with 1 pill. So we think this is tremendously exciting, and now we're trying to find other drugs that can do this even better. So what this has led to in the field of biology of aging is this search for what are fundamental things that go wrong with aging that we might be able to develop a drug to target. So we call these the pillars of aging. And there's a lot of things that might be familiar to you: inflammation, loss of stem cell function, your metabolism changes. But one we want to introduce to you today is cellular senescence. And Paul's going to tell you more about it. But what's interesting about all these pillars of aging is we've already learned that they actually are connected. So if we made a pill to target any one of these pillars, we would actually be able to modify all of these together. So what's been really important is deciding which is a pillar that's sort of sentinel. And so we think cellular senescence is that pillar. And if we just found a way to get rid of senescent cells, we would improve inflammation, we would improve stem cell function, improve metabolism, and adaptation to stress, which is resilience. So we think cellular senescence is the chicken and aging is the egg. And so we're going to target that chicken with drugs. And I'm going to let Paul take over and tell you how we're doing it.
Right. Yeah, thanks, Laura. Yes, so as Laura just mentioned, cellular senescence is one of the pillars of aging. And it's really taken on a prominent role in the field recently. And so just to describe what senescence is, so these are actually, what's shown here are just cells grown in culture. So these are cells, they could be liver cells, they could be skin cells, they could be lung cells, and put in the culture in this, and they look fairly normal. But if you stress them, if you cause some type of damage, and this is damage that occurs normally with age. So what we're seeing now in the laboratory is what goes on with aging. And what happens, these cells start to change their morphology, they look different, and we can use a special dye to stain them. It's called SA beta gal staining, and they turn blue. So these are senescent cells, and what the role of senescence is normally is that these senescent cells, when they acquire a lot of damage during aging, is they release inflammatory proteins that tells the immune system to come in and get rid of them. So when we're young, these damaged cells that do accumulate in young people to some extent stimulate the immune system, it comes in and officially gets rid of them. But what happens as we age is that our immune system doesn't clear them as well, and we accumulate them at a faster rate, so the immune system gets overwhelmed. And so we reach a threshold of these damaged cells in our body, and they cause chronic inflammation, which affects stem cells, affects metabolism, affects proteostasis, affects all the other pillars of aging. So the way you can look at this, and I think this is an analogy many scientists in the field use, it's like the one bad apple in the bushel. So this bad apple could be a damaged senescent liver cell. And so you acquire these with age due to just stress and damage, which can be just reactive oxygen species or exposure to UV. And with age and time, they accumulate. And these damaged cells release bad factors that will affect the adjacent cells. Just like a bad apple releases bad factors that drives rotting of all the other apples, that is exactly what a senescent cell does. So it leads to a damaged tissue. And it's been shown that senescence at one site, such as the liver, can affect cells in other tissues, such as the brain or lung or kidney. So a senescent cell at certain tissues or in certain tissues can affect other tissues with age. So what we want to do is develop drugs that actually can get rid of these damaged cells that prevent this spreading of senescence and aging. And what we've shown, and this is all in mouse models at this point, although the clinical trials have started, is if you get rid of these senescent cells using drugs that we've identified, we can actually treat a whole myriad of age-related conditions, everywhere from animal models of Alzheimer's, to pulmonary fibrosis, to osteoporosis, to osteoarthritis, and even frailty itself. And there's a clinical trial ongoing in the university, at the Mayo Clinic, at a nursing home to see if we can improve or reduce frailty by improving walking speed in elderly women by giving them drugs that we've shown will clear these damaged senescent cells. So this is the concept. So this is all of us, that as we age, we develop these senescent cells as shown here in yellow. So what we want to do is develop a drug, and we have some that are working well in animals that will clear these senescent cells. And you give this drug every few weeks, every few months. You don't have to give it daily because you get rid of the damaged cells, and then they'll come back as more damage starts to accumulate. So they come back again, you retreat with drugs. So that's the concept, and we've developed at this point numerous types of senolytic drugs, 2 of which are in the clinic for treating some of these age-related conditions. And so we will know within the next year or 2 whether these drugs really do make a difference to reduce severity of disease and actually slow the aging process itself. So with that, I'm going to turn this back over to Laura to talk about the mission of the institute that she directs, IBAM, and where we would like to go in the future.
Thanks, Paul. So I wanted to make a little note too that between the University of Minnesota and Paul and I moving there and our colleagues at the Mayo Clinic, the state of Minnesota is really poised to be at the forefront of development of senolytic drugs. So we're really excited to be close to our colleagues and at the U. And this has become so important to the National Institutes of Health, which sponsors most of the research at universities, that they've created a $400 million fund just to focus on this. And they want people not only who get their funding from the National Institute of Aging, but also the Cancer Institute, the Diabetes Institute, and the Heart Institute to be focused on this as well. So hopefully the state of Minnesota and the U can take the charge on this and make a lot of progress rapidly.
Can I interject?
Yes.
I'm sorry, there's one thing I was going to mention and I forgot. It wasn't in the slides, but as Laura alluded to, this pandemic, the COVID-19 pandemic, is affecting vulnerable people, people with certain underlying conditions, but also the elderly. And so we have recently shown, using a model of mouse beta coronavirus, very related to the human SARS-CoV-2, which is causing the pandemic, we've shown if you put aged mice into a facility that has this virus, 100% of them die, whereas young mice live at 100% frequency. So the old mouse is very susceptible to the adverse effects of coronavirus. And we've shown if you clear these senescent cells prior to exposure to coronavirus, the mortality rate goes way, way down. So we think part of the reason why the elderly and people with age-related conditions, such as diabetes or obesity or heart disease, are succumbing to the virus is because of this senescent cell burden that's reducing the resilience to the virus. So we think there's a number of applications for this approach, both for viral infection, but also just to keep us healthier for longer.
Yeah, so we're furiously working on this at the U. So overall, our Institute's mission, though, is really to improve the health and thereby the quality of life for the elderly in the state of Minnesota, and then apply it elsewhere as well. And we want to do this by, just as we described, trying to discover fundamental mechanisms that drive aging and the associated chronic disease that come with getting older. We're doing a lot of drug development to target these processes, and we need to find clinical outlets so we can test these rapidly and get them into the population to extend health span, not lifespan. And of course, it's the education mission is very critical as well. So we want to get lots of young people excited about the biology of aging. And I was really pleased to hear the dean say that he's going to invest heavily in creating more geriatric training so we have more clinicians to help too. So we hope that we can go back to the basics and develop the 3 R's, but in this case, it's redefining what old age looks like, getting results quickly, and realizing this to benefit all. And I should point out that many of the drugs that we're developing are natural products or repurposed drugs, so this is not going to be an approach that's expensive and for the elite only. So with that, we'll stop and take any questions you might have about our science or our institute. Thank you.
Dr. Neerharper, we have a couple of questions in the comments section, so I'll read off with 2 of them. We're wondering if nutrition can target these problems rather than a drug, and how nutrition plays a role in aging.
You want to take that one?
That's a great question. And another way of saying it, is there anything we can do now, right, before these drugs are available? It's a great point. Nutrition can. So in the field of aging, it's become clear that caloric restriction can extend healthy aging and reduce the risk of all these age-related diseases. That's not always appealing. And so the alternative is intermittent fasting, which would be take 2 days in the week and starve yourself. Or what's even more easy to handle is compressed eating. So there's very good data illustrating that if you just try and eat in the shortest period of time during any 24-hour window, that has the same benefits as caloric restriction or fasting. So just skip breakfast, not like what your mom said, but try and eat a late lunch and an early dinner, and that's it. And you can eat anything you want in that period of time. Exercise also suppresses senescence and definitely helps with all these age-related diseases. And because we know our senolytics come from natural products, I would also push you to consider lots of blue and red fruits. So the one that we've got on a lead in the COVID pandemic is actually found in strawberries. So that's what you can do right now with nutrition. Thank you.
Another question, does HGH have a role in slowing aging?
Human growth hormone?
We
actually think it's probably counterproductive to supplement with growth hormone. It's known to drive cancer. It certainly will bulk up muscle and bone strength, but there is this consequence of risk of cancer. So we are not advocates.
The other side effects, so short-term growth hormone has positive benefits. Long-term usage, the side effects outweigh the benefits. So we're not huge advocates of excessive growth hormone treatment.
One more, we could start wrapping up because I know we're on a timeline, but we can keep going. Once a drug is discovered, what is the process like, and especially what's the timeline before that drug gets to market?
That's a great question. Well, the lovely thing is if we find drugs we could repurpose, that means the Food and Drug Administration has already cleared it for human use, And it also means that they have the safety data and everything needed to apply it. So then it's just a little bit of going through the mandatory clinical trials. So phase 1, we can bypass because we know the safety profile is good. We go right into phase 2 and start to see if, first of all, the drug actually does clear senescent cells, does reduce inflammation, and then you do a large population-based study to try and see if it attenuates risk of age-related diseases. So we're hopeful we're gonna have data to prove whether these drugs work within 5 years. And we're already 1 year into it, so quickly.
Which is much faster than the average timeline for drug development for a new compound, a new entity that has to go through phase 1, 2, and 3. So we're hopeful we'll have something out there for people that's both effective, safe, and cheap, because this shouldn't be for just those with financial resources. It should be for everybody.
And then last one, how does your work relate to genetic engineering at all? And does that hold any possibility to also address aging?
Well, Paul's an expert on that, so I'm gonna let him take that one.
Yeah, so I've actually worked in the gene therapy field, so not necessarily genetic engineering per se, but using transfer of genes to treat diseases. It's my feeling that for treating aging or age-related conditions, that approach is not ready for prime time. I won't say never, but I think at this point, we're really trying to develop small molecules or biologics that can be used routinely. Problem with gene therapy or gene editing or gene manipulation, it's very expensive and it's not something that's available to large numbers of people at this point. So it's really used for treating very rare diseases. And for some of the childhood diseases that gene therapy is used for, it's $1 million of treatment. So that's just not feasible for treating age-related diseases that millions and millions of people have, as well as aging itself.
So Chad, maybe you could help folks figure out how they could help us amplify our message. We're always trying to get more people to understand how important the research is on aging and that there are new opportunities, and we'd love anybody who, you know, this tickles their fancy to help us amplify the message.
Right. So again, there's a link in the comments section, and that's something, if you want to learn more, we'll keep you updated on Dr. Nierhofer and Dr. Robbins' work. Right now with the Minnesota State Legislature, a lot of our bonding requests, which goes to the buildings that a lot of these research goes for, is being asked for right now and it's being discussed. So what we're really pushing for is people to reach out to their local legislator or maybe potentially author an op-ed highlighting this presentation, the important work that's going on there, both with current research and long-term research goals. So please fill out that link. I'll be in touch with you regarding that if you're willing to take some sort of action.
And once the university opens back up, we would love to have visitors. Once we get to that point, we're no longer social distancing. We'd like to welcome you all. If you would like to come visit, we'd love to give you a tour. We're just not quite ready for you now.
Well, I think there's a lot of institutions that are probably in that same vein, Paul. I think everybody's ready to get with that. I had one quick question going back to your discussion of the damaged cells. I would assume that you've got the therapeutics on the back end with the medication, but the other piece would be developing some type of a diagnostic tool that basically, if you're going in to see your basic local MD, that they would be able to do some kind of tool to say, well, what level of senescence do you have? Is that an appropriate assumption?
It's a wonderful and insightful question. I'll let Laura answer it.
Yeah, no, that's brilliant. So you're 100% correct. If we don't have those tools, we don't know how to best apply those drugs to people. And that's really important for safety purposes, right? You don't want to give these drugs if you don't have to. So there's a big push for that. We're doing pretty good at finding markers for senescent cells and being able to do that. But applying it broadly in a healthcare setting, that we're not there yet. So we recently had 3 think tanks with, say, 50 scientists across the globe, led by the National Cancer Institute, National Institute on Aging, saying, what's your wish list for the next 10 years if we invest so heavily in this field? And one would be a way to image and just get your senescent cell burden. So we should have invited you.
Yeah.
Good point.
That was the key message that came out of it. So very insightful question.
Well, I was just thinking with all the things we've been hearing about with COVID. I mean, that's one of the real triggers. So to me, it made sense from a diagnostic standpoint. If you couldn't tell who had what level of senescence, it'd be hard to treat that. So we will take you up on your offer for visits when that gets appropriate. And excuse me, Chad, we will publish that link, and we would certainly invite both of you to come back anytime that you would like to share an update. Maybe we'll have you back in a year or so, and we'll get a review of that. But
and hopefully we can do it face to face. We would like breakfast, so hopefully we can meet all of you.
We would very much enjoy that. Excuse me.
Well, thank you very much.
Did anybody else have any other quick questions? I know we're on a timeline, but yeah, Marshall.
Yes, I know we're recording this. Is there some way, perhaps I could ask Kathy this, that we can actually review this talk on our own with the recording? How can we watch that?
Very easy. It'll be available on the homepage of our website within a couple hours.
Thank you.
Dave Oswald.
As a former metformin user, I received a diagnosis several years ago of type 2 diabetes, and they put me on metformin and took the drug until I was able to effect some lifestyle and diet changes, lost 50 pounds, exercised more, drank more water, did all the things they told me to do, and got my A1C down into the normal range, and my glucose, all that stuff went into really good ranges, and then I got off the metformin. Should I have kept going? I mean,
well, congratulations.
Those lines separate, I'm better off staying on metformin.
So Laura, what she didn't mention is there's a clinical trial that's starting called the TAME trial.
So you could look it up if you want to Google it. It's just TAME, T-A-M-E, for targeting aging with metformin.
But it's a trial that will actually prove, because all the other data is ancillary that suggests metformin allows you to live longer and healthier. But that study will prove that we should all be taking metformin. So I can't say, yes, you should go back on it, but I think in 5 years, we will know if we should all be taking metformin, at least some dose, to keep us healthier for longer.
But I would add too, if your doctor is willing to prescribe it for you, I would pursue that. I can tell you that everybody who's associated with that TAME trial, who's a physician, is taking their own metformin. So that's the insider scoop.
I've still got a half a jar in the bathroom.
5% of people can't tolerate metformin. They have intestinal issues. And so if you can tolerate it, you have no problems, I think there's no reason not to take it. But then again, I'm a PhD and not an MD, but the field, many people in the field are taking it based on the data coming out from both clinical studies and animal studies.
Thank you.
Well, there you go.
Metformin for years, and it's kept my A1C right perfect. So I continue on it.
Great.
Good for you. It's good.
You probably didn't anticipate having telemedicine opportunities here this morning, but always good.
No, I didn't.
Always good. Well, thank you both very much again. Very, very interesting, very fascinating, and I'm sure that we will keep an interest in that. And we will activate that link. Kathy will make that available. Chad, thank you so very much for your help in pulling that together. As we always do at for our speakers, we always have an honorarium that we will be making in your names to 360 Communities, which is our local community service organization here in the Dakota County area. So we will do that. And again, my personal thanks for making time in your calendar, and we'll look forward to coming down when the U is open or having you back to visit us either way, whichever comes first.
Well, thank you very
Great.
much.
Thank
We
you
really
very
appreciate
much.
that. Thank
Thank
you.
you. Have a great rest of your week.
You too.
Okay, so with that, I know we're running just a little bit on our timeline. Anybody have any happy dollars this morning? Mr. Oswald.
If I had a spare million, I would probably offer $1 million. Happy daughter Catherine emerged from 5 weeks of quarantine on
Awesome.
Saturday,
Awesome.
and reunited with her children and her husband upstairs, no longer living in her
That's
basement.
great.
So we are grateful to God and all the great care that she got at Health Fairview Clinic in Lakeville. So good news.
That's absolutely awesome. That is really great. And we can work on that $1 million on the installment plan if you'd like.
Thanks.
That is really, really great news. Congratulations. Any other happy dollars? Excuse me. No? Well, very good. Excuse me. Well, I said we would remind you at the beginning of the meeting, we will have a short, Richard's always very good about keeping everybody on track. We'll have a short Taste of Lakeville meeting following this. And, excuse me. I would remind you of some upcoming meetings. We have the district meeting tomorrow, the Friday feature. Next week, we will have a discussion and presentation from Toastmasters. Those of you that are familiar with Rotary International has entered into a joint partnership with Toastmasters, so we will hear about that. And probably most exciting, in 2 weeks, we will have a presentation, a truly interesting presentation from Michael Caruso. Those that have been through the NC PETS, the Presidential Training Seminar that's held every year, will recognize Michael. He's a very prominent speaker, and he will be speaking to us on the 28th about making first impressions. Please check your newsletter. We will be inviting the other clubs in the area, in the district, to join us. So I'm really excited about having the opportunity to have Michael be with us. He's a very accomplished speaker. Those that have heard him and read some of his publications know he's quite animated and quite a competent individual. So let's look forward to that. So anything else, Kathy? Did I miss anything?
Not, I think we're good.
Any other questions, any other suggestions from anyone before we close? Okay, well, thanks everybody for your attendance today. And with that, we will do what we always do. We will close with the 4-way test of the things we think, say, or do. Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned? Thanks again, everyone. Have a great day and have a great weekend.